This week we're going to continue looking at some Aviation Weather Center products by parsing the winds and temperatures aloft table. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to look at the winds and temperatures aloft table that you can get for many stations around the U.S. from the Aviation Weather Center. Now this is a forecast table, so you can get a time series from it at several different altitudes from 3,000 to 39,000 feet. This is a product that I don't know if a lot of people use that are not in the aviation industry, but it's a very handy product, though parsing it can be a little bit cryptic. So if we look at a portion of the winds and temperatures aloft table here, it's relatively obvious that on the first line, we've got feet, 3,000, 6,000, and so on. We've got a station name in this first column, but then from there on out, things get a little bit more cryptic. So this week, we're going to look at the basics of parsing one of these rows, and then we'll get a little more detailed looking at some of the exceptions. This is a good exercise, though, because in meteorology, we have many files like this. Strange text formats left from when sending data actually cost a decent amount of money. So what we're looking at in these 4-digit groups, the first 2 digits are the wind direction in tens of degrees, and the next 2 are the wind speed in knots. So for example, 1913 would be a 190 degree wind at 13 knots. We also have these 6-digit groups. The first 4 are the same. 2112 would be a 210 wind at 12. But then we can actually get temperature information from the next digits. So for example, plus 12 would be plus 12 degrees. Now it is worth mentioning that the temperatures are in Celsius, the winds are in knots, and the wind direction is in reference to true north. All right, and then we'll see there's some other permutations on these groupings that can happen, but we'll deal with those when we get to them. The only other thing to note is that above 24,000 feet, suddenly we don't have the minus sign. Any temperatures above 24,000 feet are assumed to be negative. So they omit the minus sign in the 30, 34, and 39,000 foot columns. All right, so let's try to write some Python to parse out these lines. The way I like to tackle these kind of problems is start by just doing one line at a time and parsing that, figuring out the logic, and then we'll make it into a function and make it nice later. So I'm going to grab the first line of the table. I want to parse it because maybe at some point you run onto a table that has different heights. Unlikely, but possible, so we might as well parse that information. Actually, I'm just going to call this L for line. So there's our line. Now this file, if we look, is a fixed width format. So from this index character to this index character is the 6,000, from this index to this index is the 9,000, and so on. So if we go through and count in a zero-based way, 0, 1, 2, 3, and so on, we can get the index of where each of these groups ends. So I'm going to call that end char indexes. And this is going to be 4, 9, 17, 25, 33, 41, 49, 56, 63, and 70. So now how am I going to parse this file? Well, the easiest way is to step through these. So I know, for example, from 4 to 9 is going to be my first group here. I don't really care about the feet. So the 0, 1, 2, 3, the 4th, 5th, 6th, 7th, 8th, 9th. Now, why am I stopping there? Well, let's go up here and look in this table. 0, 1, 2, 3, 4, 5, 6, 7, 8. The 9th character is the first character of the next group. And just so happens that the first row has a little bit extra space there. So we've got our end characters. I'm going to create an empty list called levels. And I want to step through this sort of in this pairwise way. I want it to go from 4 to 9, 9 to 17, 17 to 25, and so on. Now you could say for I in the length of this thing, I want to take I to I plus 1, and you go all the way up until you get to next to the end element because you can't go I plus 1 from here. Well, we can do that a little bit more easily. For start index, end index, in zip, my end character indexes from the 0th up to but not including the last thing. My end character indexes from the first thing onward. So now I have two equal length lists. The first one goes from 4 to 63, and the last one from 9 to 70. So I can step through those pairwise using the zip function. We want to append to our levels list the integer of L, our line, from start index to end index. Close integer, close append. And if we look at levels, we now have 3,000, 6,000, 9,000, and so on, all the way up to 39. So that part of the parsing has worked correctly. So now let's try to decode an individual line here. For starters, I'm going to pick a line that has elements in every altitude. It's like this first line. I'm not going to pick anything tricky to start with. Okay, so line, or L, is that data line. Now for this, I think I'm going to divide it up into data groups using the exact same strategy I did here with my start and end characters. And then I'm going to print out those data groups so I can see what's there, make sure my split's working right, I'm not getting any extra spaces or anything like that, and parse the station. That seems like a good starting point. All right, so for start index, actually we can copy this line directly. Save ourselves a little bit of typing there. I'm going to print a star so I know where the starting and the ending are. The line from our L from start index to end index. Remember that's up to but not including. And a star. Let's try that to start with. Okay, that's not too bad. We're making some progress. We're getting groups that look reasonable. I'm going to go ahead and call .strip to remove any leading or trailing spaces. Okay. Now we're getting a space from using this comma separator here. If we use the addition operator for strings, then we can see that it did in fact remove all of those. All right, so great. So that's a data group. So I will now remove my print. Data groups dot append. And then my station is going to be the first 3 characters of my line. We need to create data groups. So if we look at our station, BHM, and if we look at our data groups, there we see reasonable looking data groups. They're still strings. We still haven't parsed them into numbers yet, but that's okay. We can't do that just with int because we have some more complicated things going on here. So now that I've got these data groups, I'm going to iterate through them again. Could I have done this in one loop? Sure, and maybe we'll do that when we go back and do some cleanup. But for now, we're developing. We're still figuring out how we're going to tackle this problem exactly. I'm going to iterate through my levels and my data groups. I'm going to zip levels data groups. The wind direction, we know, is an integer. The first two characters of our data group times 10, because in tens of degrees. The wind speed, we know, is an integer of characters 2 to 4 in the data group. Now we also know that if the data group is over 4 characters long, that it contains temperature information. So if the length of the data group is greater than 4, temperature is going to be equal to the integer data group, and we can just say 4 to the end. There's nothing else after the temperature. It could just be 2 digits, it could be a plus or a minus sign, could be different things going on there. If there is a temperature, we know that above 24,000 feet in level, the temperature needs to be multiplied by -1. Now what we could do here is add an else. Temperature equals none. So if the data group is longer than 4, we parse the temperature. If it's not, we set the temperature to none. Another way that you could do this would be to start off by setting the temperature to none. And then if it's there, we populate it. It's your preference. I kind of like this way personally. All right, so what I want to do, now that I've done all my parsing, is just for my troubleshooting, I'm going to print wind direction, wind speed, temperature. That should be a DG for data group. And we can look and say, does this make sense? For example, let's see, it should be 210 at 12 and plus 12, 210 at 12 and plus 12. Above 24,000, we're maintaining negative temperatures. So that all looks great. So we think we've got a basic parser up and running. Let's go ahead and make that into a function. So my function, I'm going to call it def parse wind temperature forecast. And it's going to take a file name, because I do have this in a file. Parses AWC wind temperature forecast tables. Okay, I'm going to create an empty dictionary that contains the sites for which we have a forecast. And now we can start copying and pasting. We need our in character indexes. Now we need to open the file. I'm going to use a context manager with open fname as f, lines equals f dot read lines. Now, if this were a huge file, you may not want to read everything in at once. It's not that big of a file, so we're going to read all the lines into memory to start with. Okay, now we need to read the levels from the first line. Well, we know how to do this. In fact, we've already done it right here. So we copy and paste it in. All right, now we've got our levels. But what is L? Well, it's the first line of lines. So I'm going to do is say L equals lines.pop 0. So that's going to get the 0th thing, which we know is the first line, which contains the levels. Remove it from the list because we don't want to parse it anymore. We're done with it. And assign it to L. I'm also going to call .strip to get rid of any extra leading or trailing characters that are empty, white space characters, or new lines. All right. Next, we need to read each site its own line. So each site has its own line. For line, or for L in lines, we know we have data groups. We're going to have wind speeds. We're going to have wind directions. And we're going to have temperatures. So we know we need to keep track of all those things now. And we know the station is going to be the first 3 characters. Now we again start copying and pasting. So the first thing we do is extract the data groups. Okay, the next thing we do is we're going to parse those data groups. We don't need the print statement. Parse data groups. One thing I am going to do in here is go ahead and strip any extra characters. Okay, so we're going to do our wind speed, our wind direction. Temperature is none. Okay, when we're done down here with that data group, then we need to append wind speeds dot append wind speed winders dot append winder temps dot append temperature. So that's the data groups. Now we back out one level back to each site. Sites with the station name. I'm going to set that equal to a dictionary with levels as levels. Wind speed as wind speeds. Wind direction, wind directions. Temperature as temperatures or temps. And finally, at the outermost level, we need to return sites when we're all done. So let's go ahead and run this and see what happens. We'd be very surprised if it runs flawlessly on the first go here. And we can see, first we've got a typo. We need wind speeds. Now we're seeing something interesting. We're making it past level parsing down into wind directions, but it says I can't parse empty string to base 10. Let's look at our file. So we might have an empty string which contains no wind or temperature information. Well, what do we do then? We just need to return nones. So again, there are several ways that you could do this. What I'm going to do is after we strip away, so if it's all empty characters, all spaces, then it should be an empty string. I'll say if data group is equal to empty string, then wind direction is none. Wind speed is none. Else, so if it's not an empty string, then I want to parse wind direction, wind speed, temperature. Regardless of whether it was empty or not, I need to append it so I still have a value for all of my levels. And if we do that, we see we run over the whole file, getting a dictionary back with the key of our station and the value being another dictionary of levels, wind speeds, wind directions, and temperatures. So we're done, right? Well, let's start looking through our data, making sure everything makes sense. And suddenly we run on to 990 wind directions. Well, that doesn't seem right. So next week, we'll make this parser more robust and learn about some of the more strange quirks of the winds and temperatures aloft forecast. I'll see you on next week's MetPy Monday.